Hi, I'm Jasmine Kent. I'm a software engineer from the UK. I'm living in Zurich. And today I'm going to talk about Trigger Rally, which is a simple arcade game I wrote and recently ported from C++ and OpenGL to JavaScript and WebGL. I'm also going to talk about how awesome JavaScript and WebGL are and why if you're writing new stuff, you should probably try and use it directly instead of finding a way to port your C++ code into the browser. A lot of developers, especially graphics developers, are used to C++ and will probably be trying to look for ways to shoehorn it in. But really, JavaScript is great. So, what is Trigger Rally? It's an arcade-style racing game. I wrote it in the summer of 2004. Wow, the screen resolution is a bit too low. Let's see if it works anyway. I'll show you what it looks like. It uses OpenGL 1.3 fixed function pipeline. The OpenGL shading language was not really mainstream at the time, so I didn't consider it an option. It's fairly simple, as you can see, but it was well received and ended up in a bunch of Linux repositories and had like over 1 million downloads in the first year. But then I graduated and went to work on the new version of Sega Rally, ironically enough, and I stopped working on Trigger. So, fast forward to 2012. WebGL has arrived, and it is, of course, as we all know, fantastic. I'd made a few demos, but I wanted to do something a bit more serious, so I thought I would try porting Trigger. Let me try and pull this up. But of course, Trigger used the fixed function pipeline, which is not available in WebGL. And during the course of the port, I was finding it kind of tiresome to write an emulation layer for all these features that didn't exist in WebGL. And besides, the whole look was kind of a bit 90s, as you can see. Looks like something that might be on a Nintendo 64. So I wanted to give it a graphical refresh. But rewriting the graphics is quite a lot of work, so I looked around for libraries that could help. And I stumbled across 3.js, which probably some of you have heard of. It's really great, and I'll talk about it some more in a minute. But first, let me show you the result of a few weeks of hacking. So as you can see, it's still fairly simple. The game has actually become even more simple. It's just one car and one level, but the graphics are a little bit improved. It's got shadow maps and some subtle reflections on the cars, which actually you can hardly see now that I think about it. But it's definitely better. And this is still very much a prototype. I've hardly scratched the surface of what 3.js can do. And it was all incredibly easy to do. So as I discovered over the course of this port, which only took a few weeks, the whole stack, from the browsers through JavaScript, WebGL, and of course 3.js, is just really easy to work with. And I've done a lot of coding in C++, writing native apps, and this just doesn't compare. It's way faster, way more user-friendly, or way more coder-friendly. I'm pretty sure that 3.js was the right choice. So let's talk about each layer of the stack in a bit more detail. First of all, JavaScript. Coding it is easy, and debugging it is also easy. It's almost fun, in fact. You can do it right in the browser. Probably soon with things like Cloud9 and other IDEs, we'll be able to write our code in the browser as well. You can also share code with the server. For example, the server that this is running on is written in Node.js, which is also great fun, highly recommended. I should probably mention garbage collection, which is something a bit scary for people who are used to C++. It is an issue, and if you create a lot of objects in your animation loop, they're going to add up. In fact, let me try and show you the memory profile of this thing. So as you can see, this game is not doing a great job at not creating objects. This sawtooth memory profile is the result of lots of small objects being created and then garbage collection occurring. And each of those garbage collection events could cause you to skip a frame if you're quite close to your budget for a particular frame rate. Nonetheless, it's pretty easy to fix. I just thought I should mention it. So the next layer in the stack, WebGL, I won't go into a lot of detail. I'm sure you're all quite familiar with it. But one nice thing about it is that it's very robust, or at least fairly robust. The browser gives you a layer of defense against bugs in the graphics drivers, which you wouldn't have if you were working with a native app. So although it's somewhat simplified, that is a huge win. And finally, let me mention 3.js, which, as I've said several times already, is fantastic. And it has a ton of features. It's super easy to use. You can just look through their examples page to see all the stuff that it can do. Obviously, there's a lot of things that I'm not using yet in Trigger Rally, but I'll add them in time, I'm sure. But really, the most important thing that you don't see from looking at the examples page is the way it's structured. And for me, the most important thing is that 3.js gives you the ability to transition in a very granular way from letting 3.js manage the scene graph to doing your own rendering code. In my case, for example, there's a few trees, but it's not the most interesting vegetation, and I wanted to increase the density. But each of these trees is rendered using 2 draw elements calls, one for the leaves and one for the trunk. And each draw elements call has a certain amount of overhead, especially in WebGL, where you've got to do a round trip through the JavaScript system for each call. So what I wanted to do was merge the meshes for groups of trees into a single large mesh and then issue that as a single draw call. Let me show you what that looks like. So at first, the performance was really not that great because of the overhead of the draw calls. And once I'd merged them into single meshes, I discovered that actually 3.js was adding quite a lot of overhead to each mesh. It's written in a way that it has multiple rendering front ends. So WebGL is just one of them. It can also render to Canvas or SVG. And as a result, the mesh data is not really optimized for WebGL, and you end up wasting quite a lot of memory. However, it gives you a way out. You can use buffer geometry objects, which let you provide your own WebGL data directly. And all I had to do was rewrite the mesh merging code to use arrays instead of 3.js mesh storage. And suddenly I was able to do this. And as you can see, the geometry appears and disappears in blocks now, rather than as individual trees. Yeah, you can also change other parts of the pipeline. I haven't done that yet in this version, but you can write your own shaders, you can do your own rendering, you can do custom textures, procedural code, that sort of thing. So that's the WebGL and 3.js stack. And I hope I've given you the impression that it's pretty cool. But developers with a native background are still probably a little bit skeptical of JavaScript, and indeed it does have its flaws, but it's better than its reputation. There's Douglas Crockford's quote that JavaScript is the world's most misunderstood programming language, which is very true, I think. He wrote a book called JavaScript: The Good Parts, which I highly recommend, by the way. Although I don't use his inheritance model. But it's very good anyway. So, delivering web apps using C++ is possible. There are options you can use, such as native client, which lets you host the code provided your user is running Chrome and you install it from the Chrome Web Store, which is not really the best solution. You can also use this thing called Inscripton, which actually cross-compiles C++ code to JavaScript, which is really cool and it works really well. But the result of the code is really hard to debug. I mean, it's almost machine code. So I'd just like to reiterate that, I mean, the productivity you get working directly with JavaScript and WebGL is just fantastic. It's really easy to learn, and it's great fun. I mean, what more could you want, really? Well, I guess there is one thing you could want, and that would be more features. WebGL 2, in fact, hopefully should be coming this year. And when we have that, we'll have a much bigger feature set than the current generation of consoles. And that's going to be really exciting. I can't wait to see what people come up with using that. It's going to be an interesting year. So thank you very much. Is there any time for questions or?
Yes, we have time for questions. Is there any question? I come to you.
Just a question about WebGL 2. I have not heard of that before.
So
where did you get that rumor from?
This rumor is that OpenGL ES3 is in secret development within Kronos and is expected to be released. Its code name is Haiti, I think, and it's expected to be released later this summer, hopefully. And WebGL is, of course, based on OpenGL ES. Once ES3 comes out, we should expect WebGL 2 shortly afterwards.
Okay, are there any more questions?
The original game was in open source. Is that available somewhere?
Yeah, it's on SourceForge. You can, from Ubuntu or whatever, you can just install it with apt.
Okay. Can you explain more how you did the sound of the car?
The sound is done using the web. I assume you're talking about the WebGL version, and it's done using the Web Audio API. I really wanted to do a Firefox compatible version using their audio data API, but it would have been a fair bit of work because the Web Audio API actually gave me a lot of tools that made it really simple.
Okay.
I can try plugging in the sound and see if it works. Yeah, so it's got a few different loops that are just played continuously. There's an engine sound, which is modulated by the RPM of the car. There's a skidding noise, which is kind of hard to hear, but skid around here. That's modulated by the amount of sliding velocity of the wheels. There's a wind noise, which you can hear if I go really fast, maybe if I don't hit things. There's a transmission whine noise, which is the high-pitched squeal you can hear, which is modulated by the wheel velocity rather than the engine velocity. And there's also a few instantaneous sound effects like crashes and the noise that you get when you pass through a checkpoint. So it's pretty simple, but it's all done with Web Audio.
Are there any more questions? We still have time for more questions.
Douglas Crockford, and the book is JavaScript, The Good Parts. It's quite a small book, but it's really good if you're fairly new to JavaScript. It covers all the gotchas.
Did you have any problems adapting this game to different browsers?
Actually, it was really easy. I give credit there to 3.js, but it worked immediately in Chrome and Firefox. At the time I wrote it, Opera was still fairly flaky in the WebGL implementation, and I've been a bit remiss in testing it in Opera since then, so I'm not actually sure if it's working there or not. I really need to do another pass and test Opera. It also works in Safari if you enable it in the flags. But no, I had no trouble whatsoever. It was really easy.
Okay, we have time for one more question, then we go on to the next presentation. 1 second.
Hey, what, if anything, are you using for debugging?
I use the Chrome tools mostly. They're really great. You just pull up the developer tools and you have... Oh, this is a compiled version, unfortunately, but you can see the scripts and drop in breakpoints, step through it, everything. Also, the heap snapshot is very useful when you're doing memory debugging. All right, thank you very much.
Okay, thank you very much.